Okay, guys, in this video, we are going to also take a look at partial derivatives, but it's going to be a little bit more complicated to find them. So this is tangent of x to the 6 minus 9x squared y squared plus 8y to the 4th. All right, so first the partial with respect to x. Now, forgive me, I'm not going to use the same notation they do, but you should be familiar with that. So this looks kind of like a 6, but it's not really a 6. It's like the other way 6. I don't even know how to say it, but whatever. This just stands for partial derivative with respect to x, and this one is partial derivative with respect to y. Now here we actually need the chain rule. Here's what the chain rule says. Imagine that we are taking tangent of something. And this is granted a really big something, but it doesn't matter. So it's like a tangent of a thing. So I'm going to say tangent of a thing. So how do I take the derivative of tangent of a thing? Well, derivative of tangent x is secant squared x. So first I'm going to say, okay, tangent of a thing is secant squared of the same thing. So that will stay. Okay, so this whole thing, whatever I got, I'm just going to have to rewrite. Never change the argument. Like tangent of a thing is derivative secant squared of the same thing. So it'll just be that. And you're going to have to multiply by chain rule by the derivative of the thing with respect to x. So this is going to be the derivative of x to the 6 minus 9x squared y squared plus 8y to the 4th with respect to x. All right, so the first part, do not mess with that. Don't try to quote unquote simplify it or take something out or put something in there. You are not allowed to do that, okay? Secant squared of some hideous thing that you leave alone and don't touch it. It's going to be in your answer. But what about the second part? How do I take the derivative of that with respect to x? First, let's figure out if there are any terms that don't have an x. If there are no x, that those terms will drop out. So I can see that 8y to the 4th does not have an x. Derivative of a number is 0. That's going to drop out. Okay, so the secant squared, I'm just going to rewrite. Everything here is going to be the same. And now the next thing is, what about x to the 6 with respect to x? So that's a normal derivative. That's just 6x to the 5 according to the normal regular power rule. But what about this other one, the mixed one, 9x squared y squared? Okay, so because I'm taking the derivative with respect to x, I am going to first write all the terms that don't have an x. And then I will take the derivative with respect to x. So think of these terms, this 9y squared, as a number. So this is like number x squared, like 5x squared. This is constant multiple, and we keep it. Okay, so even though 9y squared has a variable, but that variable doesn't change, because remember, when you're taking the derivative with respect to y or x, you're treating the other variables as constants. So this is just going to be 9y squared, we keep constant multiple, and derivative of x squared is 2x. Okay, so that's going to become 18xy squared. So this is minus 18xy squared. And we are basically done. Usually we would just put that whole expression though in the front. So we're clear that it doesn't have anything to do with the secant squared part. So that one I'm just gonna rewrite. Okay, so hopefully that's right. Now, how is this going to be different if I take the derivative with respect to y? Well, the secant squared will be the same. So I'm actually going to just copy paste that part because it's just still a tangent of its thing is secant squared of the same thing. It's just that now I have to take the thing, so the x to the 6 minus 9x squared y squared plus 8y to the 4th. And I'm going to take the derivative of that with respect to y. Okay, so that's going to be the difference. All right, so first, identify if there are any terms that do not have a y. Well, this one doesn't have a y, right? So that's going to drop out. Okay, so what will happen? 8y to the 4th doesn't have an x. So that's a normal derivative. So we just bring 4 down, that becomes 32y cubed. What about this other term? Okay, so here you have to be careful. So 9 9 is a number. X squared is also a number. So this is like a constant multiple, and derivative of y squared is 2y. So this will become negative 18x squared y, right? And then this is a plus. Okay, so that's going to be in the front over here. Okay, hopefully that's right.